We shall now discuss open sets. Before we discuss an open set, we will talk about what is called an interior point. You take the circular disc of radius, say 1 centimeter, whatever, 1 meter, or radius r, and then you take any point lying inside that circular disc, on the circular disc. Then you can always draw another small circular disc around that point, so that that circular disc will lie completely in the original circular disc. You can just try it out with a pencil and paper. Then that point is an interior point, and this will be true for any point in that circular zone which is inside the boundary. Without the boundary, we will not talk about any point in the boundary. Such points are called interior points. So interior point is a point in a given set U if for that particular point x in U, I can always find the radius r, so that when I draw an open ball of radius r around x, the whole ball is completely contained in U. That is, Bxr is a proper subset of U. That is what is the meaning of open set. Now, that is what is the meaning of interior point. Pardon me. So we will call a set open if each and every point is an interior point. So let me go over once again. So if I give you a set U and take a point x in U, we will call x an interior point if I can find a radius r and I can draw a ball of radius r, open ball of radius r around x, such that that ball is completely contained in U, that is a proper subset of U, then x would be called an interior point. And if every x that is in U is an interior point, it will be called an open set. The interesting fact is that if you look at the open ball itself, every point in the open ball is an interior point, and hence the open ball is an open set, which we had mentioned earlier in the last talk. That is why we have mentioned those two sets. So now we are going to look at the link between open sets and closed set, which is sometimes taken as the definition of a closed set. That a set whose complement is open. But instead of doing so, that particular definition which is used can be actually proved when we take that sequential definition, which is much more intuitive in nature, which is much more clear. Because if you talk about a structure of a set with respect to the structure of another set, it is much more difficult to understand the true nature of the set. Rather than, it is better to talk about a set based on its own structure rather than relating it to the structure of some other set. The relations can be forged, relations can be spoken about, but defining it in terms of some other set, in relation to some other set, is not possibly a very interesting approach. So that is why we have taken a very slightly different approach here, following T.W. Corner. Subset of U is open, U in Rn is open if and only if its complement, U complement, there is a set of all elements in Rn which is not in U, is closed. So let us start proving it. So let U be open, and our aim would be to prove that U complement is closed. So what I am supposed to do? I am supposed to take a sequence xn in U complement, and if that sequence xn converges to some x star, my job is to prove that x star also belongs to U complement. On the contrary, assume that I have a sequence which converges to x star and sequence xn is in U complement. I'll assume that x is not in U complement, so it must be in U. So we are taking a contrary assumption. So this will be a proof by contradiction, as you understand. The proof by contradiction is one of the greatest tools in the toolbox of the mathematician. Since U is open, any point is a interior point. So x star is an interior point. So I will be able to find an epsilon, no matter how small, such that the open ball with radius epsilon would be completely included in U. Now xn, the sequence xn in U complement goes to a x star. So taking that epsilon greater than 0, which I have used for the ball, we can always find an n naught, so that for all n greater than n naught, xn minus x star, that distance is strictly less than epsilon. This is the definition. So what does it mean from this? What do I mean here from this definition, from this expression, that whenever n is bigger than n naught, xn is element of the open ball around x star of radius epsilon, which means xn must be in U for all those n's bigger than n naught, because this whole ball is inside U. But that is a contradiction, because we have assumed that xn is a sequence in U complement. How can elements of such a sequence be in U? So our original assumption that U complement is not closed, that is x star is not in U, is wrong, and hence U complement is closed. So if U is open, U complement is closed. Now suppose U complement is closed, U will be an open set. Let us see. So if I want to show that U is an open set, what I have to show is that if I take any arbitrary point in U, that must be an interior point. So if I want to prove U is open set, I'll again use that big tool, the proof by contradiction, and I will assume that U is not an open set. So if I assume that, what I have to show that if I assume such a thing, I will come to a contradiction. So if I assume that U is not an open set, then there must be at least one point which is not an interior point. Suppose x star is such a point which is not an interior point, which means give me any epsilon you want, whatever ball I draw around that x star, there will be at least one point which will not be in U. So there must exist an x which such that xn is not in U. So now I start choosing the epsilons. First I'll choose epsilon is 1, then I'll choose epsilon is 2, epsilon is half, then I'll choose epsilon is 1/3 and 1/4 and so on. So that's epsilon n is some 1 by n. So for every such n, I choose epsilon as 1 by n. Then for that particular epsilon is 1 by n, I find an xn which is not in U, but xn remains in the ball. So there must be an element in the ball which is not in U. So xn is not in U, but it remains in the ball. But from this expression norm xn minus x star strictly less than 1 by n, what does it mean? It means that xn is going towards x star. I am not going to prove this for you. It simply means norm of xn minus x star can be made as small as I want, because 1 by n can be made as small as you want. So xn is going to x star. Now since U complement is closed and xn is, we have shown that xn is goes to x star, then x star must be in U complement, but that is a problem because you have assumed that x star is in U. Right. So this is a simple way of arguing through the method of proving by contradiction. So again we have reached a contradiction, and hence U is an open set. Hope that you have understood the proof. Understanding proofs are very important because that sharpens the way you reason in mathematics. So thank you once again, and do look into the proofs very carefully. We can discuss them when we meet next time.